Today we're going to look at taking balancing chemical equations and all the conversions we've been looking at and moving on to reaction stoichiometry, where we start with something and we've got to figure out how much of something we're going to produce. Or when we are starting with two things and we need to figure out which one's going to run out first. But today we're going to focus on, this is what we start with, this is how much we're going to produce. So I gave you an easy equation here to balance to begin with. So it's HCl, hydrochloric acid, plus zinc, was going to give us zinc chloride and hydrogen gas, H2. So first thing we have to do, as we can see from down here, step one is balance our equations. So if we look, we have hydrogen, we have one hydrogen on the left hand side and two on the right hand side. So we're going to put a 2 here. And now our hydrogens are balanced. Hopefully they stay that way. And then we are going to see that we now have 2 chlorine. We're going to look at the other side, 2 chlorine, and we've got 1 zinc on both sides. Super easy to balance. So that step is complete. Next, we're going to look at what the problem's asking. It's giving us 43 grams of zinc, and it wants us to find grams of hydrogen gas. So we have 43 grams of zinc. As I showed here in step 2, you need to get to moles of your starting substance. So we need to find out how many moles of zinc we have. So we're either going to divide by our molar mass or Avogadro's number. Since we have grams, we're going to divide by our molar mass, or multiply by 1 mole over our molar mass, which is the same. So we need to look up the molar mass of zinc, which is here, and it's 65.409. grams per mole. So we are going to take 43 and divide by that number. And we get 0.657401. That's how many moles of zinc we have. Now, if we look at step 3, we're going to use our molar ratio from the balanced chemical equation. And that is to get to what we're looking for. So our balanced chemical equation, since we don't have anything on these lines, they're all 1s. And we need to figure out, we need to go from how many moles of zinc do we have to how many moles of hydrogen gas is it going to produce. Which, as you can see, they are a 1-to-1 ratio. So we will multiply by 1 mole of H2, which I get from here, over 1 mole of zinc, which I get from here. So obviously if you multiply by 1 divided by 1, you're going to get the same number. So we're going to take that same number. The only thing that changed, we got rid of our moles of zinc, and now we have moles of hydrogen gas. So now we know how many moles of hydrogen gas we want, but we got to figure out what our desired solution is, which is grams. So we need to either multiply by molar mass or Avogadro's number. Since we want mass, we're going to multiply by the molar mass. So we have 0.657401 moles of hydrogen gas. We're going to multiply by the molar mass of hydrogen gas, which we're hydrogen is 1.00784. And we have 2 of them. So that will get rid of our moles and tell us how many grams of hydrogen gas we have. So we are going to times 1.00784 times 2. So take our previous answer, multiply by 1.00784 times 2, or 2.01568, the molar mass of hydrogen gas, and we get 1.32511. grams of hydrogen gas. Our problem, we started with 43.0 significant figures, so we're going to look at the first 3 here. So we will end up with 1.3. That 2 is going to stay a 2 because 5s always round to the even number. Grams of hydrogen gas. Okay, so 4 easy steps get us from our starting material to our desired solution. Let's run through one more example of this. This time I have 3.87 times 10 to the 23rd molecules of Fe2O3, and I need to get grams of iron is what I want to find out. So first we need to balance this. I got 2 iron on the left hand side, so I need 2 iron on the right hand side. I've got 3 oxygen on the left hand side, 3 oxygen on the left hand side, or right hand side, 1 aluminum on the left, 2 aluminum on the right. So another one that's fairly simple, fairly straightforward to balance. And we have now balanced our equation. So step 1, or that was step 1. Step 2, we need to get to the moles of our starting substance. So we're going to divide by molar mass, or Avogadro's number. So we have 3.87 times 10 to the 23rd molecules. And we need to divide by either the molar mass or Avogadro's number. Here, obviously, we want to divide by Avogadro's number. And 3.87 E23 divided by 6.022 E23 equals 0.64264. Moles of Fe2O3. After that, the next step, step 3, is use our molar ratio from our balanced chemical equation to go to what we need. So we're going to take our 0.046 or 0.64264 moles of Fe2O3, multiply, we want to get here, so 2 moles of iron over, we've got 1 mole of Fe2O3. So we're essentially going to multiply by 2. We'll get rid of our moles of Fe2O3 and we'll be left with moles of iron. So times 2, 1.28528. And after that, we need to find grams of iron, which is our final step, convert to the desired solution. So we're either going to multiply by molar mass or Avogadro's number. In this case, we're looking for grams again, so we're going to multiply by molar mass. So we'll take our 1.28528 moles of iron. We'll multiply by the molar mass over 1 mole, which, when we go look at iron, it is 55.845 grams for every 1 mole, and that will leave us with grams of iron. So now all we have to do is multiply our previous answer times 55.845, and we get 71.7768. grams of iron. Once again, we had 3 significant figures. We can see that here in our problem. So we're going to round to the 3rd significant figure. So our final answer would be 71.8 grams of iron.